Welcome to Learning with Philemon. In this video, we will be looking at how atomic models have developed throughout history. In the kinetic theory video, we discussed that Democritus is often credited with the idea that all matter is made up of atoms, which were thought of as indivisible spheres. Although this seems obvious nowadays, it is fascinating that thousands of years ago, anyone could have come up with such an abstract concept. Since then, our understanding of atomic structure has greatly improved, and in this video, we will see how different scientists contributed to our knowledge. In 1803, John Dalton, an English chemist, hypothesized that the atoms of each element will be identical, but still held on to the idea that atoms are small spheres that are indivisible. In 1897, J.J. Thomson, an English physicist, was experimenting with cathode rays and discovered the electron. In 1904, he proposed a model, which is now called the plum pudding model, in which the atom has a positive charge, but there are negative electrons distributed inside of it. This is the first time the atom is not thought of as indivisible, but contains components. In 1911, Ernest Rutherford, a physicist from New Zealand, conducted an experiment which consisted of firing positively charged alpha particles at a thin sheet of gold foil. The results did not match Thomson's model. We will use the simulation by PhET by the University of Colorado to visualize this experiment. In this first part, we will see how the alpha particles would interact with the gold foil if the atoms had the structure proposed by Thomson. Here we see a cloud of positive charge, with the negative electrons as blue dots. The particles going through are the positively charged alpha particles. As can be seen, the alpha particles go straight through the atom, with little or no deflection. As the alpha particles are positive, they are attracted to the negative electrons, opposites attract, and repelled by the positive part of the atom. As the charge is evenly distributed, the alpha particles are neither repelled or attracted enough to change their direction. This is not what Rutherford discovered in his experiment. In this part of the simulation, we see the alpha particles as purple spheres. Most of the alpha particles go through the gold foil, but some of them are deflected a lot. This would only make sense if there was an area where there was a high concentration of positive charge that would repel the alpha particles. Rutherford proposed that in the center of the atom there is a nucleus which has a positive charge. The yellow dots are in fact the nucleus of the atom. In this view of the simulation, we see the nucleus of a gold atom, and we can see how the alpha particles are deflected. Decreasing the size of the nucleus decreases the amount of repulsion, as there are less protons to repel the alpha particles. So in Rutherford's model, we have a positively charged nucleus in the center of the atom, and the rest of the atom is mostly empty space, with the electrons orbiting the nucleus. In 1913, Danish physicist Niels Bohr, using quantum physics, explained that electrons can only exist in specific energy levels. Electrons can transition from one energy level to another by either absorbing or emitting a specific amount of energy. It was only in 1932 that James Chadwick, an English physicist, discovered the neutron, which is a neutral particle that is located in the nucleus. Finally, we reach the atomic model that is used in Key Stage 3 and GCSE level physics and chemistry. A nucleus with neutrons and protons, and electrons in specific energy levels around the nucleus. Remember that most of the atom is empty space, and this diagram is not to scale. Of course, this is not the full story. The atomic model is more complex than this. Although it is a simplified model, it does help us explain some properties and chemical reactions at Key Stage 3 and GCSE level. A more detailed description of the atomic model will be given in the next video. Check out future IB A-level videos that consider more complex models. Check out the links for resources that will enhance your understanding of atomic structure. If you haven't already, please subscribe to my channel for more content. Stay curious.